Let's get you thinking straight away. For these 4 examples, are the steps shown on your screen correct or not? Pause your video and have a think about it. Hopefully you've spotted that none of these are correct. And for the examples here, it's for the same reason. If we've got a variable as part of a fraction or in a bracket or in a root, then we cannot just add or subtract it. We must get it out of that fraction, that bracket or that root first. In the last example, hopefully you spotted that although we have divided the numerator of the fraction, we haven't done it here. I've taken away a here, so that doesn't work. We've got to make sure we're dividing the top and bottom of the fraction by the same thing. Chance to practice this. Pause the video, think through which of these are correct. The first one's not, because we've got a fraction and we've taken away our variable from the top and bottom. The second one is correct because we've divided the top and bottom by the same thing. The third one, we had our number here trapped inside a root, so we cannot just take that away from there. That's not correct. Here we've divided top and bottom both by x take away 2, so that's fine. Here we've divided the denominator by pq. We've divided this part of the numerator by pq, but we haven't done to this part, so that doesn't work. We haven't divided all parts of the numerator. And the last one's incorrect as well, because our number here, we've got it as part of a fraction. We can't just add or subtract that when it's trapped inside. To simplify these algebraic fractions, the first thing we need to do is to factorise top and bottom if we can, and then look to cancel. So here we can factorise the top because we can see x is a factor of both x squared and x. We can't factorise the bottom at all, but now we've got this, we can see we can divide top and bottom by x plus 1, and that will just give us the answer x over 1 or x. Here we can factorise the top. We can see 2x is a factor of both of these terms here. And on the base, hopefully this looks familiar. This is an example of difference of 2 squares. And it's the difference of 2 squares because here we've got a square term, we've got x squared. Here we've got a square term, we've got 2 squared, and it's being taken away. If you've remembered this, you might remember the shortcut where we know it's going to factorise to this. We've got one with take away, one with plus, and then we've got the square root of 4 there and the square root of x there. If you can't remember how this works, don't worry, but just remember with an example like this, if we've got a variable squared and then a constant, just a number, we can look to factorise it. And what can help is to think about that as x squared plus no lots of x, take away 4, and then we can use our factorising skills on this. So here we'd need to think of a pair of numbers which added to 0 and multiplied to -4. Thinking as always about the factors of this first, -2 and 2 fit the bill, and yet they add to 0, so then we can factorise it. So it's really useful to be able to remember this difference of 2 squares, but if you can't, remember you can work it out thinking it through in this way. From here we can now look to simplify our fraction further. We can divide top and bottom by x plus 2, and that will give us 2x divided by x take away 2. Pause the video, have a go at these 2 practice questions. We can't factorise the numerator here at all, but we can factorise the denominator. So we can factorise 3x out of both those terms. And then what we've got in the brackets here looks familiar. We can divide top and bottom by 2x plus 3, which will give us the answer 1 over 3x. We can factorise the top here, and we can factorise the base. To do that, we need to be thinking about a pair of numbers which are going to add to 3. They've got to multiply to 2, so that's got to be 1 and 2. We can now look to divide top and bottom by x plus 1. And there's our answer. For the questions you need to be able to do, it's important to be confident with negatives. This first, we've got a negative just outside the bracket. Remember, that's the same as negative 1 multiplied by the terms inside. So we've got negative 1 times 4, and we've got negative 1 times negative y gives us positive y. And we can rearrange that, make it a bit neater, just by putting y first, so we're not starting off with our negative term here. So we can see the impact of having this negative outside the bracket is just to change the signs of what's inside. So for the next example, we'll have minus 2x plus 9. And again, we can rearrange that to make it a bit neater. We could write it as 9 minus 2x, although that's not essential. It comes in really handy when we're trying to do things like simplify the fraction we've got here. You can see we've got the same terms, top and bottom, just with the signs reversed. So it doesn't matter whether I do this for the top or for the base. I'll go for the top here. That's the same as this, which we can see is just our denominator here. And we can check that. So negative 1 times x gives us negative x. Yep. Negative 1 times negative 1 gives us 1. Yep, we've got that here. So we can see that they are equivalent to each other. And now we've got that, we can just simplify it, divide top and bottom by x minus 1. And remember, when we're dividing it by x minus 1, we're actually leaving just 1 here and 1 here. So we're going to have minus 1 over 1, just minus 1. This example here, we've got double brackets, top and base. We need to look for the same terms in both. So here we've got a 3 and a 3, we've got 2x and 2x, but we can see the signs of these have been changed. So on top here, this is the same as minus 1 times 2x minus 3. So writing this out in our fraction, and then we can divide top and bottom by 2x, take away 3. I could write this x plus 1 down the base in brackets. We don't need it, so it's just easier not to. What we do need to do is tidy up the top here. So thinking about what we've got, minus 1 outside the bracket, so that'll be minus 2 plus x. And it's always good if we've got a negative here at the front and our variable's positive, just to rearrange that to make it a bit neater. Pause the video and have a try with these examples. For the first two, the negative outside has the impact of changing the sign of the terms inside. And for the second one, we can just write it around the other way to make it a little bit neater. For the third question, we can't factorise the top. We can factorise the base. And hopefully you spotted, using this idea we've practiced here, that if I change it on top, although it wouldn't matter whether it's top or base, this is the same as this. So we can simplify by dividing top and bottom by 5, take away 2x, which gives us minus a half. And in the last one, we can rewrite x minus 5. If we put a negative outside the bracket, that would be 5 minus x. So we can divide top and bottom by that. And then tidy up. This is your first task. There's a copy of it also on Show My Homework. So choose your challenge, choose where you want to start in here. Couple of hints to do with this. If we look down at number 7, it may look really tricky to start off with, but for the 4x take away 1, that works as the difference of 2 squares. Because here we've got 2x squared, and here we've got 1 squared, and they're separated by a takeaway. Also on the AMBER ones, be careful when you get to questions like 10, where the coefficient of x squared is more than 1. Remember for that, when you're factorising it, we would want a pair of numbers which add to -7. So looking at the coefficient here, but would multiply to 2 times -15. So they'd have to multiply to -30. So be careful of those as you go through. Make sure you check your answers and you make sense of any you didn't get. Now we're going to move on to multiplying and dividing algebraic fractions, and we'll be using those simplifying skills you've been practicing as well. Quick reminder, if we're multiplying a pair of fractions, we just multiply the numerators, multiply the denominators, and then simplify if we can. A really useful skill to remember though is to cross cancel. So here we've got multiples of 7. So if we divide both of those by 7, here we've got multiples of 3, divide both of those by 3, and we've got much nicer fractions to multiply out, and we don't have to worry about the simplifying that we would have had to have done here. So it's really useful if you can see ways to do that before you multiply out the fractions. So here we can see multiples of 2. So we get 5x over 2y. And it's not a problem if you don't do that. You could have just gone straight to 10x divided by 4y and then simplified it. But it does make life a little bit easier to spot that shortcut in the first place. When we're dividing fractions, remember that's the same as multiplying by the reciprocal of the second fraction. And a useful way we can try and remember that is we keep the first fraction, we change the sign to multiply, and we flip the second fraction. We look to see if we can cross cancel, and we've got multiples of 3 here, and then we multiply out. So again, we're dividing here, so we keep the first fraction, change the sign to multiply, flip the second fraction. And looking for any cross cancelling, we've got multiples of 3 here. We've also got variable x in both of these, so if we divide both of those by x, we're just left with 1. So we just get 5y over 16. If you find the cross cancelling confusing, don't worry. It is fine just to multiply these out. So we would have had 15xy over 48x, and then we can look to simplify that. But doing it this way just does save a bit of hassle sometimes. Pause your video, have a practice with these. Here we can divide by 2 top and bottom. So that's 2xy on top over, what am I doing? If I divide by 2, I'm just left with 1 there. So 2xy divided by 7. We're dividing here, so we keep the first fraction, change the sign, flip the second fraction. And we can't simplify that at all. Again, we're dividing, keep the first, change the sign, flip the second, and then we can divide top and bottom by y, top and bottom by x. We've got multiples of 2 here, so we end up just with 3 over 5. Again, if you had have written that out first as 6yx or 6xy over 10yx and then simplified it, that's absolutely fine. These examples get trickier. It's really useful to look to cross cancel before we multiply them out. So we've got multiples of 3. So r plus 2 over 1. And we've got 3r plus 6. Now, we can factorise this. We can take out the factor 3. And this is going to help us. And it might be useful here to put back in that fraction sign in the 1, just so we can see it a bit more. Because then we can see we can divide top and bottom by r plus 2. So that will just give us 7 divided by 3. This next one looks a lot trickier, and it is, but it's all steps you can do. So first of all, we've got to be thinking about factorising any of the numerators or denominators we can. So this is going to factorise. We can also factorise the denominator on that side. So we're going to be looking for a pair of numbers which are going to add to -3 and they're going to multiply to -10. It's got to be -5 and 2. We can't factorise the numerator there at all. We can factorise the denominator. They've both got x in there. So that'll leave us x squared minus 25. And then hopefully you can see we can factorise this further because we've got our difference of 2 squares. So that will go to x plus 5, x take away 5. Remember, for that difference of 2 squares, we use the square root of this and we use the square root of this, 1 positive, 1 negative. So let's write this out a bit more neatly. And we'll change multiply and flip the second fraction. And let's look to see where we can cancel down. So we've got x plus 2 and x plus 2, x plus 5 and x plus 5, x minus 5, x minus 5. So that gives us just 3 times x. And sometimes when you see questions like this, it may look a bit confusing the way it's asking us to simplify it to ax, where a is an integer. But it's actually really useful because when we get to the answer, we can just check that we have managed to get to that form. So yeah, 3 is an integer, so we've managed to get there. Pause the video and have a try with this. Again, there's lots going on here. We'll first look to see if we can factorise any of these expressions. So here we need to find a pair of numbers which add to 2, multiply to 1. So that'll be 1 and 1. I could write this as squared. Normally that would be a better way to write it. But because we're going to look to try and cancel this down, it'll be easier just to leave it like this. We can't simplify the denominator on this side. Here we've got our difference of 2 squares. Remember, if you find that difficult to spot and to remember, we can always think about that as x squared plus 0x, take away 25, and then we're looking for a pair of numbers which add to 0 and multiply to negative 25. We've got x plus 1 on the base there. So looking to cancel down, we're left with x plus 1 all multiplied by x minus 5. And unless we're asked to expand it in the question, absolutely fine to leave it like that. This is the final task for today, and you've got a choice of challenges in here. 3 things to be careful of as you go through these questions though. Look out for expressions like this, where it's the difference of 2 squares. So here we've got 5x all squared. Here we've got 3 squared. So the shortcut to factorise that is we know it's going to be 5x plus 3 in one of our brackets, 5x minus 3 in the other bracket. Also look out for quadratics like this, where the x squared term has got a coefficient greater than 1, because that means we might have to split the middle term to factorise it. However, sometimes you might notice the coefficient is a factor of the other terms here. So in this case, we could just divide everything by 2. And then we've got a much nicer quadratic to factorise. Got to be careful there if this is part of a fraction. We'd also have to divide, if this was the top, we'd also have to divide the bottom by 2, for example. Good luck with these. Check your answers once you're done with them.